So today I am going to talk about MySQL architecture and enhancement. Since 5.7 8.0 is something interesting topic what we have, and I thought the 8.0 is come up with a pretty good feature, and just talked about myself. My name is Lalit. I work as a bug analyst for Percona. And can you do this? Nice. Okay. So that's all about me, and let's continue with the presentation. What the agenda for today? Our agenda is MySQL. First, we'll talk about the MySQL 8.0 architecture, not in a brief, just to overview and we'll talk more about the component which are changed in 8.0, and we'll talk about the important enhancement which are pretty impressive, I can say, and which was a painful area for customer, lot of users, and how those introducing by those feature, how 8.0 solve our problem. So we'll talk about in architecture, we'll talk about the in-memory and on-disk architecture, and in enhancement we'll talk about the data, how it impacted the the way it stored metadata, the way it changed for InnoDB, the way it changed in terms of security and replication. And I'll take all question in the end of the session. While creating, I thought there is much we can talk about it, but I'll have this presentation as just an informative way, and again soon I'll have one webinar on this just to elaborate this thing more and the features. So if I talk about the database, the structure on memory and on disk is very important. So let's think about it, that you are ordering food, you are sitting in a restaurant. If you are ordering, it will come, it will take some time, okay, and so it's our on structure. You can consider as on structure memory, on structure architecture. And if you are in hurry, you can take your food from takeaway, right? So that's like your memory structure. So how data works, we store data on disk, okay, and in order to fetch that data, rather than going again and again to the disk, we store that data recently or frequently accessed data in memory, so we can gain the performance advantage, and that's the reason we have this kind of a concept as on disk and in memory. In memory, when I talk about the MySQL, this highlighted area are highlighted area is pretty what I can say improved in MySQL 8.0. That's the reason we'll talk more about the undo tablespace and temporary tablespace. But just to have an overview how MySQL architecture is, I'll cover this basic thing. So let's talk about the memory component first, and then we'll move to the on-disk components. Okay, buffer pool is a common area, main area in the memory, which store data and indexes in the pages. Okay, so how it works, it's store your frequently accessed data. So it works on LRU algorithm, recently used algorithm, and it has so every time it's like the sequence where your data always insert in the middle, and depend on how frequently you're accessing. If you're accessing frequently, it will move to the young pages, upper side in the head, and if you are not accessing your data, then it will move to the tail. And eventually, if you are not using that data at all, it will evacuate from the queue. So that's how it works. So interesting thing about this buffer pool area is it is configurable dynamically. Till 5.6 it was not possible, but in 5.7 this variable InnoDB buffer pool size is dynamic, and you can change the size of buffer pool on the fly. To monitor this, you can use show engine status command, and inside that you can get the information that how many space is left, how many spaces utilized, and how many pages I have. So moving forward, apart from this buffer pool, memory needs few supportive factors. Okay, buffer pool cannot work alone, and that's the reason there is a concept of, there are other components like change buffer. So what change buffer does is, so let's say if I am changing anything in database, my primary indexes will stick on the same page of the data, and if I'm changing anything, it's easy to change and update cluster index. But for the secondary indexes, it's not same. For the secondary indexes, my indexes and data store randomly and is get updated randomly. So for performance wise, it's really hard to write on disk randomly. So that's the reason we have this area change buffer, where in this area we keep index changes in change buffer, and whenever in next time any query accessing the same data, I pull that data in my buffer pool, and change buffer will merge those changes to my data files. So that's how I avoid frequent IO on disk for the secondary indexes. It is configurable using the InnoDB change buffer buffering variable, and you can monitor this variable again in show engine InnoDB status area inside the InnoDB buffer and adaptive hash indexes. So that how many pages no, and you can change it. For example, if you're thinking that it's not enough for you, the default size is 25%, and you can increase it up to 50% of your total buffer size. Next, adaptive hash indexes. This is more like if you have let's say 5 GB or let's say 20 gigabytes data, and if you have 32 gigabytes RAM, so yeah, you have enough memory. So your buffer can act like your in-memory database. But definitely there is a problem with indexing, because on disk we have a B-tree index. We cannot use that in memory. So that's the reason this concept, adaptive hash index will help to, if I am loading that data in memory, I can create a hash indexes in memory, so I can now access that data very frequently, and I can utilize the indexing concept. This variable is configurable using InnoDB hash indexes. The only disadvantage here, I can say, when there is a lot of concurrent load, you should check your show InnoDB engine status and the semaphore area. If you are seeing a lot of read-write latches waiting for your read-write transaction, it's better to disable it. So our advice is to test it, okay, see how it works in your environment. If you think that there is a lot of read-write latch, wait, just disable it. Or there is one more option. You can it can be group in different groups. You can do that also. Log buffer, again, this is for performance. So we use redo logs for crash recovery in MySQL. Again, we don't want to write so frequently on disk. If I am changing anything, if I non-committing data, if I am running long transaction, I don't want to write that data immediately again in disk. So that's the reason we have this log buffer which hold that redo log data until it gets commit. And there is a flushing mechanism. Depend on the value of InnoDB log flush transaction commit, your data will flush from your memory to data. So for example, if it is 1, which is the default one and the safest one, if you are running the if it is I mean for a second also or a millisecond also, you cannot compromise downtime. In that case, this thing will make sure that my in each commit my data will get write to my disk. So there will be no loss of commit data. If you are keeping value to 2, that in that time it will write into file system buffer, that means OS. So in case your OS crash, your data will be gone. 0 is unsafest one, which means if you are doing any changes, it's just flushed to your log buffer. So in case of your MySQL crash, your data will be lost even though your OS is up. So this is the flushing mechanism we have, and you can use any of this, and the default one is 1, which is the safest one. Okay, let's move to the OnDix this thing. So we have a system table space where in 5.7 we used to keep our data dictionary or undo log, all those stuff inside this system table space, but now in 8.0 it's changed, and the only thing we have is double write buffer and the change buffer. So double write buffer is just to make sure that in case of a crash, if data is not getting written properly to my table space, I can get a good copy of my data from the system table space, and that's how I'll recover my data. General table space, let's say for now by default we have InnoDB file per table option enable, which will have one table space for each table. Okay, and let's say you have a 70,000 table, and you have 5 customers like that, and they each have 50, 60 like that. So it's really difficult to have that number of files on file system. In that case, this will help you general table space, where what you'll create a common table space for each customer, and you'll put all 70,000 tables inside that table space. So I mean that's the best way, and it support all kind of file formats, which is not supported by InnoDB file per table. So that is the advantage we have. Okay, just to see how it looks when you start your 8.0. Auto.cnf is a common, is not something changed, but it will keep your server UUID, which is the unique ID for your server. This is interesting. Your bin log is by default enable in 8.0, which is changed in 8.0. So but the good thing about is, even if you forgot to notice this, it will automatically truncate this bin log after 30 days. So there is one more variable introduced, which expire log days variable is set by default to 30 days. So that changes there in bin log. New thing here is you can see this MySQL IBD file. This is something new, completely new. This is our data dictionary. So earlier we used to store our data dictionary in our system table space. This is IB data. Now we have a dedicated table space for data dictionary to store a metadata information, which we'll see, which we'll discuss in detail, which is very, very interesting. We have by default undo log now. So earlier, if you are initializing your database, by default they will get created in your system table space, that is IB data. And the problem is, I'll cover that in detail as well. This is the default thing we have. Okay, so this is something which is interesting in 8.0. So undo table space contains undo log, and in 8.0 by default is not a part of a system table space. It's create a separate undo log, and the beauty of this is you can truncate this undo log automatically or manually. You can set like that. So what was the problem earlier in 5.7? If this undo log part of your system table space, and if you are running long transaction, it's so painful that if that transaction is long running, your system table space size will go and keep going on, and it will increase, and there is no way to reduce it because you cannot truncate it. So this automated and manual truncation option give the feasibility to truncate it on the fly. Okay, that means you don't need any downtime. You can truncate it automatically, or you can truncate it manually. For example, there is a variable InnoDB undo log truncate option that you can use it, and it will truncate your undo log automatically. Manually, so there is a condition. If you are setting it to automatically, by default you have a 2 undo log and it will work fine. If you want to do this manually, it needs 3 undo log, because automatically and manual they can go together. So if you are doing any manual truncation, automatic need those 2 undo log. So that's the reason, that is a limitation, or that is a condition you can say we have. And again, if 2 undo log is not enough for you, you can add on the fly. You can drop them on the fly. Okay. So that feasibility we have, and this is the syntax, create undo table space. Yeah, so by default we have 2, and now I am creating the third one by giving the data file and the name. You can get the information about it, how many undo log I have, and information about undo log table spaces in the information schema InnoDB table space table. Temporary table space, this is also a majorly change in 8.0. So it has a concept of global and session now. So earlier there were only one temporary table space. Now we have this global and session table space concept, where I'm having a dedicated table space for global operations. And if you are creating any temporary, if you are performing any temporary operation, you can have those in your session temporary table spaces. Okay, and the moment you log off from your session, it will truncate those temporary table space. That means immediately the work is done, session is closed. There is no extra amount of space is acquired by these logs. Enhancement, let's go through quickly. Data dictionary, this is the change. So what problem I have earlier, I have a file system where I have my FRM files, I have system table space and with MySQL table, and I have few InnoDB tables. So everything is mixed, not centralized. So that's the problem. And the problem is, for example, if I have a 90,000 table, I need to read 90,000 FRM, and that's the problem, because as a DBA for a monitoring, I may use information schema as my as a source of information. And that was a problem, and that's the reason it is a bottleneck for information schema to optimize it and give the better result. But with the change of 8.0 and the data dictionary implementation, that's changed, and now you can see we have a separate table space with the InnoDB engine that we can optimize, and there is no limitation like what we have in 5.7. Tablespace encryption. So in 5.7 we have file per table encryption enabled, but now I mean that is something partially, okay, because what about other table spaces and my binary log, my reader log, right? Whatever I have in my data directory, that's not encrypted. So this thing is improved drastically, I can say, in 8.0. So now we have system table space encryption, general table space encryption, undo table space, redo, and as well as I have a binary log and reader log encryption, which is introduced in 8.16. I mean it will release soon. So configuration thing, one common scenario, I'm a DBA, I'm a changing variable now. After I'm on vacation after six months, and some other guy comes, some maintenance activity comes, he reboot the system, and my change is gone because I just set variable globally, but I didn't set it for persistent change. So that's the problem. So to avoid such thing, if you are doing any changes, you can use the set persist option, and immediately you can know it will log, it will set those settings for your server, as well as it will write those configuration changes to this file, MySQL auto.cnf file, which will keep your changes. So next time if you are restarting your database, you'll have this setting. So this is the separate file stored in JSON format. Okay, we are about to end, only 2 slides. Logging. So this thing is changed. Log error was verbosity is 2 now. So earlier we used to see no start sequence, stop sequence. Now only thing you'll see is warning and errors in when you start your MySQL by default. So if you want more information, change it to 3. And you can suppress particular warning if you see that, okay, packet drop and you're aware about it and it's annoying, it's unnecessary taking your space in error log, you can suppress that particular warning or error. So that is what we have. And this is the last change in replication. Channel wise you can add a filter. This is something new. Yeah, done. anyways, I'll share this slide, so no issue. And security wise, this is the last one. We have a concept of role now. So rather than giving the individual privileges, you can have a particular role. For example, for a DBA I have a set of privileges, for developer I have a set of privileges. So that kind of thing you can do with the roles. Automatic, I mean, there is a you can, if you're creating a user, you can automatically assign particular role that using this variable. This variable is there. Password policies and password protection is more what you can say, more improve in A.O. Means for example, if you are changing your password earlier, you can just log in and you can change the password, but now it will ask you what's your current password. So that kind of improvement we have. So this is what Percona is. Percona is the fork of MySQL, and we have few enterprise feature in our Percona, then performance scalability with a few new feature. And this is the tree of MySQL family and how it goes and how Percona goes. So that's all, guys. I mean, thank you. So I'll have a webinar on this. I know each feature is very interesting. So I'll have a webinar on this topic, and you can join that, and we'll have a hands-on on that how each feature work and what benefit we can get from it. Thank you.